Assalamualaikum and good morning. My name is Amyliana binti Mahassan. My matrix number is B0516100206. My FIP title is Glass Waste as Sintering in Ceramic Tile Productions. And my supervisor is Professor MADYA Dr. JARIAH binti Muhammad JUOI. I will start with introduction. Ceramic tile is typically a type of tile made of white or red clay which is mixed with other natural materials such as quartz, feldspar and water. Clay is a fine-grained natural rock or soil material which combines one or more minerals with traces of metal oxides and organic matter. The main function of clay is give plasticity and characteristic binding to the product. Next is quartz. Quartz has been the only source of silica. Silica is the name given to the group of minerals made up of silicon and oxygen, the two most common elements of the Earth's crust. The function of quartz is help to ease the discharge of gases processed during drying and firing. Next is feldspar. Feldspar is obtained from natural resources. It is usually found in pegmatic rocks of the granite type, which can be considered a mixture of feldspar mineral together with quartz and mica. The function of feldspar is a fluxing agent. The high price of feldspar is because of it comes from natural resources. Using feldspar in the formulation ceramic tile is also lead to high energy consumption because the melting point of feldspar is high, which is at 1100 degrees Celsius to 1450 degrees Celsius. Next, I will continue with the problem statement. The use of feldspar will lead to high cost because the raw material are gained from natural resources, and it is difficult to gain compared to waste glass. In the previous study, the researchers has been used waste glass in the formulation of ceramic tile. The problem statement is the determination of suitable weight percentage of waste glass to substitute feldspar and the optimization of sintering temperature due to replacement of feldspar in order to produce ceramic tile that meet the industry requirement. The objective of this study is to evaluate the effect of different weight of waste glass in replacing feldspar on the ceramic tile physical properties sintered at different temperature. And the scope of this study is the first one is using soda lime silicate glass to replace feldspar. The second one is the size of the particle of material used is below than 75 microns. And the third one is the analysis of the experiment is physical analysis, which is water absorption, porosity, bulk density and linear shrinkage. For the literature review, here is the list of journals that I have referred. The first one is from Ibdahood and Building 2018, which is the article title is Recycling of Waste Glass as Aggregate for Clay Used in Ceramic Tile Productions. And the second one from Mustafi et al. 2011, Effect of Waste Glass Powder on Physical Mechanical Properties of Ceramic Tile. And the third one is Development and Evaluation of Ceramic Tiles Using Waste and Solid Materials for Ibrahim and Ambali 2019. And the last one is Waste Colored Glasses as Sintering in Ceramic Tile Productions from Huang et al. 2006. Okay, next I will continue with the methodology. The procedure starts with material preparation and formulations. The material which is clay, quartz, feldspar and soda lime silicate were grind and crushed into powder by using planetary ball mill machine. Then the material was sieved separately into size of 75 microns. Next, the material were mixed according to the formulation as in the table shown. Then the experiment will continue with the fabrication, which is forming and sintering. In forming process, the mixed material were pressed into square shape of size 80 mm times 80 mm by using hydraulic pressings. The stress applied is 2.5 tons. For the sintering process, the sample were heated at 950 and 1050 degrees Celsius by using carbonate furnace Abraham. The heating time is 1 1 hour and the heating rate is 5 degrees Celsius per minute. Next is the results of this study. The analysis that have been done for the sample is physical analysis, which is water absorption, porosity, bulk density, and linear shrinkage. So here the result for water absorptions. The lowest water absorption when the feldspar was substituted with SLSG of 25 weight percentage, which is composition of batch B, which is sintered at 1050 degrees Celsius, and the highest water absorption is batch F, which is sintered at 950 degrees Celsius. So here the result for porosity. The highest sintering temperature has the lowest percentage of porosity. The lowest result of porosity is sample with composition of batch B, sintered at 1050 degrees Celsius, which is given value of 1.2%. The maximum percentage of porosity, which is value of 16.19% at sintering temperature of 950 degrees Celsius, which composition that contain 25% weight percentage of feldspar. I'll continue with the result of bulk density. The minimum bulk density, which is 1.01 gram per centimeter cube, happened at composition 2, which is batch B that sintered at 1050 degrees Celsius. This trend is only applicable at clay and cross feldspar SLSG at ratio of 70, 5 and 25 weight %, where the amount of bulk density decreasing with the increasing amount of SLSG. With the change of temperature, the bulk density tend to decrease. The last one is the result for linear shrinkage. The linear shrinkage increased as the temperature increased. The sample that sintered at 950 degrees Celsius is the only sample that meet the requirement, which is the value of linear shrinkage is between 0.02 mm to 0.8 mm. And the last part of this presentation is the conclusions. All the sample cannot be claimed as ceramic tile because all the sample did not meet the requirement of Malaysian standard ISO. From the outcomes, a few conclusions can be drawn, which are physical properties was tested to all samples. According to the analysis, sample of batch B, which are sintered at 1050 degrees Celsius with the ratio of clay and cross feldspar SLSG, 75-25 weight percentage of ratio, has the lowest amount of water absorption, which given value of 1.40% and porosity, which is given value of 1.42%. This is due to the presence of both feldspar and SLSG in the mixture.